Hey guys, today I'm going to be doing example 29.3 from the textbook. Basically what we have is a beam of electrons moving and then catching in towards a circular field, kind of like that. So we have kind of two different parts here as the electrons are moving from here to here. And then they're catching in this electric field that's kind of going around like that. Some values we have is that the electrons are accelerated from rest through a potential difference of 350 volts. So we have 350 volts, and then they enter a uniform magnetic field. This is the uniform magnetic field here, and this has a radius. Radius is equal to 7.5 centimeters. So because we have two parts of this problem here, we have kinetic energy and potential energy, which when added together is equal to 0. What we'll basically do here is break these down and solve for the velocity to try to find how fast the particles are really spinning in their radius here. So for kinetic energy, we know it's 1 half mv squared, and for the potential energy, it's going to be the charge. Since we're working with electric fields, it's going to be the charge of the particle times the change in voltage. So what we want to do here is solve this out for V. 1 half, or let's do this. We'll do V squared on this side. We'll subtract Q and V to the other side. And then divide this by m and 2, so it becomes this right here. And it's v squared, so we can go ahead and just take that out and put a square root box around it. It's kind of unclear, but it's 2q delta v. Then we'll want to just plug in some basic values for this. The charge of a particle, of an electron, is 1.6 times 10 to the minus 19. Our change in voltage is 350. And we know the mass of an electron to be 9.11 times 10 to the minus 31 kilograms. And this is in coulombs. And if you type that all into your calculator, you should get 1.11 times 10 to the 7 meters per second. Now we're going to take this second part here and imagine the electron entering into the magnetic field with this speed. So we'll take our new equation over here for the magnetic field. Our magnetic field is equal to the mass of the electron times velocity over E times our radius. So all we need to do is plug in some basic values for this. So we get the same mass, 9.11 times 10 to the minus 31 times our value right here, 1.11 times 10 to the 7th, all over 1.6 times 10 to the minus 19 times R, which is 0.075 meters. Yep. And once we saw that out, we should get a Tesla rating for the magnetic field, which is equal to 8.4 times 10 to the minus 4 Teslas. Sorry, I kind of covered that all up there. But yeah, B is equal to 8.4 times 10 to the minus 4 Teslas. Our formula right here to find the electric field with our velocity and our, I guess you could also label this as Q, same thing, but the charge of the particle times the radius. So, hope that was helpful. That's all I got.